Running your PHP app with the default timeouts is like balancing a Jenga tower during an earthquake. One shaky external service and the whole thing collapses. Timeouts are way too high by default, they are not affected by max execution time, and code often forgets to handle connection timeouts. In this video I'm going to talk about how you can configure timeouts in your PHP application to keep control during failure scenarios. Moin, I'm Benjamin and PHP performance is my main focus for the last 10 years, helping thousands of developers, companies and open source projects along the way. Why even care about timeouts and achieving fast failures? Because PHP can only handle a limited amount of parallel requests at the same time, configured in Apache or PHP FBM. When you have enough of them waiting for a long time because of timeouts, then at some point other perfectly fine requests will be rejected at the web server level because there's no available capacity to process them. Let's review the status quo of timeouts in PHP. In general, timeouts are controlled by the PHP INI setting default socket timeout, which is at an incredible high 60 seconds by default. This applies to file get contents, fopen, DOMDocument, SOAPClient and more internal APIs. Let's look at some code to understand it. This 60-second default applies to internal functions that are using streams, such as file get contents, fopen, DOMDocument, or the SOAPClient. Curl is applying no timeout by default, and if the backend is hanging, then also the PHP request would wait indefinitely for it. But you would be wrong to rely on max execution time to rescue you. The 30 seconds default is not applying to I/O functions. First, if an I/O function is running for a long time, then the Zend and PHP virtual machine is not actually getting to a state where it checks that the execution time is reached and aborting the script. Second, even on Linux, the max execution time is measured in CPU time and not in wall time. That means if you're waiting for I/O, the max execution time is not actually increasing. It's best to look at some code to understand how this works. So we have this example here. I want to explain it a little bit. So we reduce the max execution time to 1 second so that we have a short example to test. I have included a timer PHP here. The timer PHP is just a simple include that takes the start time using the high resolution timing API of PHP. If you're not familiar with it, it's a new API that replaces microtime for benchmarking because it uses a better timer API from Linux or other systems than microtime uses. Then we register a shutdown function. It also takes the high resolution timer, it computes the difference and calculates this in seconds, so it's human readable. And what we do then in the script is we run an endless loop. We perform one I/O wait operation. Sleep is an I/O operation, but this could be a database query or an expensive HTTP call taking a long time. And then we perform some expensive CPU wait time, which is the password hash function, which encrypts the string into a password, and this is taking quite some time. So let's run this and see how max execution time works here with regard to I/O time. So running the script, we expect it to run just 1 second based on max execution time, but it actually runs 4 seconds. And the reason for this is that it only calculates the 1 second of CPU time that the script takes, but there is around 3 seconds of I/O wait time through the useLeap function here, which is not counted towards the max execution time. And therefore, if you have scripts that have long-running I/O, then max execution time is not the right way to prevent scripts from running too long and aborting them. Connection timeouts are the next problem. They are usually forgotten. In network communication, there are usually two independent timeouts in effect. First, the timeout that is measured for read-writing on the connection, and then second, the timeout for the connection itself, so waiting for actually connecting to the machine and communicating with it. Let's see how this works in practice. In this script, we set the default socket timeout to 2 seconds. We include our timer as before, and then we perform file get contents against an address that doesn't exist, so it's not reachable. So when we run the script, PHP connect timeout 2, then we would expect it to be terminated at 2 seconds. That's true. So here, this is the connection time. So it waited 2 seconds before it decided that this server is not reachable. For local connections, 2 seconds or even 1 second might be way too high. If you know that a service is not available in the local network, you can usually know this in like a very few milliseconds. And the timeout, the connection timeout for this should be configured way lower. By now it should be obvious that this slow failure mode by default is bad for application stability during a failure. For user experience reasons, you want the users to see a failure page quickly enough, not after 60 seconds. And for capacity reasons, you want to keep your PHP process free for handling requests that are not relying on the unavailable services. As a first step, you should therefore reduce the global timeouts to a more manageable number of 5 to 10 seconds. What makes you feel comfortable? You can change this in code, like I'm showing here, using ini set function or globally in the php.ini. To reduce the timeout for file get contents, you need to use the stream context create function to create a context, and you specify HTTP options here. So you can specify the timeout, in this case to be 1 second, or even below 1 second, so let's say half a second. However, be careful because of TCP inner workings, Linux, and how PHP works. A very low timeout might not actually be recognized, and there's, let's say, one option, TCP no delay, that is not set by default, which might be required to be set here as well to get low timeouts. So then we have the file get contents call against a local address that's not available. Let's run this, PHP reduce file get contents timeout, and there we see the script stops after half a second, so the timeout here works perfectly fine. If you are making HTTP calls through the DOMDocument API, then you also need to use stream context create, again HTTP set a timeout, and then you need to pass this context to libxml set stream context, and then it's being used for outgoing HTTP requests. So if you load a remote document with DOMDocument API, then this will work. So PHP reduce DOMDocument, and we see there's the timeout stopping the script after 1 second, again against an endpoint that is not available. For the SOAP client, it's similar but different, because the SOAP client is not using the PHP streams API internally. We cannot configure it using a stream context. Instead, we have to use the default socket timeout for the read-write timeout, and then we have to set a connection timeout using the SOAP options, and then again making a call against an endpoint that is not available, not reachable. Then we find out that we have the error could not connect to host after 1 second, so the script is aborted. Continuing with timeouts for curl, you need to set curl opt timeout for the read-write timeout, and you need to set curl opt connection timeout or connect timeout for the connection timeout. So these are configured separately compared to the stream context API, is where the timeout is used for both settings. Then we can determine that a timeout happened. If the HTTP code is 0, then the script was aborted. We don't have a response. So let's see and test this. Reduce curl 1. So we see here after 1 second the timeout happened. We see the error message. If you need more control over the timeouts in curl, there are also options that allow you to configure the timeout in milliseconds. So let's say 2000 milliseconds for read-write timeout and 1000 milliseconds for the connection timeout. And again, we run this. After 1 second, the script terminates. Last but not least, I want to show how to configure timeouts for the Predis library because it's quite widespread. You need to set the option timeout and then read-write timeout. So timeout is the connection timeout, read-write timeout is the timeout that applies when the connection is already present but nothing is happening on it. And then in this case also we set TCP no delay to true. Otherwise, for a very low timeout, we have seen that it doesn't work this way. It takes way longer to stop the script if the timeout is reached. So let's see how this works in practice. We run the reduce Predis script, and then we can see after 260 milliseconds the script is stopped with an error. And if we go up here, then we can see operation timed out. So this is the error happening on the PHP stream when the timeout is reached. I hope this was some helpful advice on timeouts in PHP for you. I also have a video on max execution time on this channel that you should watch. And please subscribe to the channel or our newsletter. The link is in the description. Bye!